Welcome to this video notes series on 5.4 linear applications. So to solve linear application problems, okay, what that means is we're going to end up writing an equation and then using that equation to evaluate it, to evaluate the situation. So for this first problem, a car rental company charges a $30 base fee plus 20 cents per mile driven. Write an equation in slope-intercept form to represent the total cost based on the number of miles driven. How much would it cost to go 12 miles? Well, the first thing we need to do before we can even answer this last part of it is we need to come up with the equation. So one of the first things I'm going to look for is it says it wants it in slope intercept form. So I know I'm needing to get it into that, which is y equals mx plus b. So y equals mx plus b. The second part is, well, let's figure out if I can find my m and my b in the problem. So a car rental company charges a $30 base fee. So if you see keywords like base fee or initial cost or starting out or something like that, this is typically your y-intercept, also known as your b value in the problem. Now the next part is it says it's plus 20 cents per mile driven. Okay, typically when you see that, you see a keyword like per, well, that's your x. So this is plus 20 cents per mile, so that is your m. So this is where we get the rate of change from, is in that part of it. So now we'll set it up as an equation, y equals mx plus b. We know m and we know b now. So y is equal to 0.20x plus 30. Okay, now we're going to use that function in order to evaluate it because now we're getting into the final step of this. How much would it cost to go 12 miles? So what that means here is that we are evaluating this input value. So evaluate the input. So in order to do that, we're going to use Desmos. And how we're going to do that is we're going to take this y equals part of it and we're going to change it. We're going to change y equals to f of x equals. So what I'm going to type in Desmos is f of x equals 0.20x plus 30. Then on the line below it, I'm going to type in f of 12, and it's going to spit out an evaluation of that function. My bad. Okay, so we're going to go into Desmos, and we're going to have 0.20x plus 30. So f of x equals 0.20x plus 30. Okay, this is going to end up making a picture, which we could use it if we wanted to. Here, if you find your y-intercept, it's crossing the x-axis. That is your initial value or your base fee. The second part of it is now we're going to type in f of 12. And what that's going to do is it's going to produce an evaluation at 32.4. And because we're dealing with dollars, we do not want any fractions. So this is not a good answer, but 32.4 is a good answer. Okay. Let's go back in to our problem here. So we're going to take f of 12. We saw that it equals 32.4. Well, let's put this in context here. What this means is that it would cost $32.40 to go 12 miles. Okay. So this is what we're looking for. A lot of times in multiple choice answers, of course. This is what we needed in order to create it, though. And then again, we just changed the y in the function to be f of x equals. So let's look at problem 2. Problem 2 says a hot air balloon starts at an altitude of 200 feet and begins ascending at a constant rate of 50 feet per minute. Okay, Let's see. Write in a linear equation in slope-intercept form for the balloon's altitude after X minutes. What is the hot air balloon's altitude after 7 minutes? Okay. So I don't know why it does that, but okay. So what we're going to look for is, does it tell us any information about a B value or an M? So it starts at an altitude of 200 feet. So there is your initial value. So initial value, your y-intercept. Okay. So B is 200. It begins ascending. So we got ascending at a constant rate of 50 feet per minute. So there is your X. And it's 50 feet. So we got our M. Now ascending means you're traveling in a positive slope here, a positive direction. So ascending means we're going up. So it's plus 50x in this case. So our equation, we're going to have M is equal to 50. So our equation is just going to simply be y equals 50x plus 200. Again, to create this in Desmos, we're going to change the y to be f of x equals 50x plus 200. And we need to evaluate it for what is the hot air balloon's altitude after 7 minutes. So we're going to evaluate it at f of 7. Okay. So let's go back into Desmos here. And we're going to say, again, let me just clear these out. So f of x equals 50x plus 200. We're going to evaluate it at 7 minutes. So f of 7 is 550. And there you have it. So f of 7 is equal to 550. And what that means is the hot air balloon will have ascended to an altitude of 550 feet after 7 minutes. Okay, last question. A water tank is being drained at a rate of 3 gallons per minute. After 10 minutes, there are 40 gallons remaining in the tank. Write a linear equation in slope-intercept form. So we do want it in slope-intercept form to represent the amount of water remaining after X minutes. And then how much water is remaining after 15 minutes. So again, we want it in slope-intercept form. Do they give us a y-intercept in this one here? It says the water tank is being drained at a rate of 3 gallons per minute. So I'm going to go ahead and identify that as my y-intercept. So it's drained at a rate of 3 gallons per minute. So in this one, our M is negative because it's draining. So that means we're going to have a downwards direction here per minute. So negative mx. After 10 minutes, there are 40 gallons. So they did not give us a initial value. So we know that we started at 10. So this is going to be our X value here, X1. And this 40 is going to be our Y1. So we're going to have a point this time of 10, 40. And what we're going to do is we're going to change that point by plugging it into the equation here. We're going to come up with the point slope form of it. So y minus y1, so it'd be y minus 40 equals m, which is negative 3, times x minus 10. Okay. Next thing I do is I'm going to go ahead and take this, and I need it in slope-intercept form. So I'm going to move this minus 40 over to make it plus 40. So it's gone. Then I'm going to distribute. So we're going to have negative 3x plus 30. So y is equal to negative 3x plus 30 plus 40. And we'll finish out the equation. Y is equal to negative 3x plus 70. So the nice thing about this is now I can see that this is the initial tank capacity. It's a 70-gallon tank. And we want to know after 15 minutes how much is remaining in that tank. So here's the final part of it. How much water is remaining after 15 minutes of draining? So let's create the function. We're going to create it so we can type it in Desmos. So instead of y equals, we're going to put f of x equals negative 3x plus 70. And then we're going to evaluate it for 15 minutes. Okay, we're going to go back into our Desmos here. So let's create this one. So it's f of x equals negative 3x plus this initial capacity of 70 gallons. So there's the initial value. At this part here, after about 23 and 1/3 minutes, or about 23 minutes and 20 seconds, then the tank would be completely empty. But we want to figure out what is it after 12 minutes, right? Or was it 15? It was 15 minutes. So a couple of ways that we could do that. First of all, we're just going to do it this way. F of 15 tells us it's going to have 25 gallons remaining in the tank. I could have also just said x equals 15, and I go find the intersection of that. So at 15, it would be 25 gallons. So after 15 minutes, we have 25 gallons there. So our final statement is the water tank will have 25 gallons remaining after 15 minutes of constant draining.